वंस अगेन वेलकम टू आवर ऑनलाइन प्लेटफॉर्म। ये जो क्वेश्चंस है ये हमने केमिकल काइनेटिक्स के न्यूमेरिकल प्रॉब्लम्स और ये हमारे AIPMT 2010 से हमने इसको लिया है। द क्वेश्चन इज दैट फॉर द रिएक्शन दैट इज डिकम्पोजिशन ऑफ N2O5 इनटू NO2 मॉलिक्यूल और O2 गिवन रिएक्शंस है and the value of the rate of disappearance of N2O5 is given that the rate of formation of NO2 and O2 is given respectively as it means हमें इस केस में rate of formation of NO2 और O2 को calculate करना है। तो we have the four options. So before solving this question, first of all we have to write down the rate of reaction in terms of the rate of disappearance of reactants and rate of formation of the products. So इसको थोड़ा सा squeeze कर लेते हैं। The first of all write down the chemical reaction is N2O5 gaseous state decompose into two molecules of NO2 gaseous state and 1/2 of O2 gaseous. So first of all the rate of reaction is equal to minus disappearance of N2O5 is equal to this 1/2 rate of formation of NO2 molecule and 1 divided by 1/2 rate of formation of oxygen molecule. Or you can also rewrite here this term in terms of 2d of O2 by dt. So that is the rate of reaction in terms of reactant and product. Now the given value is the rate of disappearance means disappearance minus rate means d by dt of N2O5. N2O5 is given as 6.25 into 10 raised to power minus 3 mole per liter per second. So that is the given parameter and we have to calculate the rate of formation means plus d by dt for NO2 is our target and second target is rate of formation of oxygen d of O2 by dt. So we have to calculate these two values by using this particular relationship. So now we just compare to find out the value of these two we have to compare the required parameter and given parameter. So in this case the given parameter is minus d by dt. So we just take the minus d of N2O5 by dt, that is the first part, is equal to required is the NO2 and NO2 is in this part. So that is equal to plus 1/2 dNO2 by dt. Okay, so we just rearrange this equation. So d by dt of NO2 is equal to twice of minus d by dt of N2O5. So that is a relationship. Now we have to just put the given values. So that is equal to 2 into 6.25 into 10 raised to power minus 3 mole per liter per second. Just multiply it. So that is 12.50 into 10 raised to power minus 3 mole per liter per second. The first is the final result. You just compare with ABCD also. So the given ABCD we have to result in terms of 1.25. So we just rearrange again. So it is 1.25 into 10 raised to power minus 2 mole per liter per second. So that is the first result regarding the formation of the NO2, that is 1.25 into 10 raised to minus 2 mole per liter per second. Now next target is to find out the oxygen. So the second part is the simply we compare with the minus dNO2O5 by dt. is equal to twice of dO2 by dt. So that is the simple result. We have to rearrange this relationship. So on the second part is to find out the value of this one. So minus disappearance of the N2O5 by dt is equal to twice of O2 by dt. So just rearrange this equation. So plus dO2 by dt is equal to simply 1 by 2 N2O5 by dt simply. So we just put the value. The disappearance of N2O5 is given as 6.25 into 10 raised to power minus 3 mole per liter per second divided by 2. So result will be that is comes out to be 125 into minus 3 mole per liter per second. So that is the result for the formation of the rate of formation of the oxygen. So just compare the previous result by the option A, B, C, D. So in the previous result, the value for the dNO2 by dt was 1.25 10 की पावर minus 2 mole per liter per second. So questions के अंदर क्या है? Respectively, it means the first value for the NO2. So first value for NO2 is 1.25, option B and D, but according to the second oxygen 3.125. D is just skip out, only B. So B option is the right answer for these questions. So that is the first question from the chemical kinetics. Now the next question is this one. Next question is given that for the reaction nitrogen and hydrogen and formation of the ammonia, if the rate of that is the formation of the ammonia is 2 into 10 की power minus 4 mole per liter per second, the value of disappearance of the hydrogen. So for the given reaction, first step is the हमेशा first step क्या रहेगा? You have to write down the rate of reaction in terms of the reactants and in terms of the product. So that is the given reaction. So the rate of reaction, first one, N2 is the reactant, so minus dN2 by dt. Hydrogen is also reactant, so minus 1 by 3 hydrogen by dt. And finally for the product, it is equal to the plus 1 by 2 d ammonia by dt. So that is the rate of reaction in terms of reactant and product. Now the given value is the given value given that in this question, the d ammonia by dt, that is the formation of the ammonia rate, is equal to 2 into 10 raised to power minus 4 mole per liter per second. The rate of formation of the ammonia, and our target is to calculate rate of disappearance of hydrogen. That is our requirement. So from the given relationship, we just compare. The first one is the ammonia, second is the hydrogen. So we have to just equal to each other. You just to use this relationship. So minus 1 by 3 hydrogen rate is equal to plus 1 by 2 ammonia rate. So according to the required parameter, we have to just rearrange the equation. So ds2 by dt is equal to simply 3 by 2 d ammonia by dt. So it means the rate of disappearance of hydrogen is equal to 3 by 2 times of the rate of formation of the ammonia molecule. So we just put the value. So it is 3 by 2 into, the value is the 2 into 10 raised to power minus 4 mole per liter per second. So 2 cancel out. So the final result is the disappearance of the hydrogen is simply 3 into 10 raised to power minus 4 mole per liter per second. Now we just compare this result with the options A, B, C, D. So option A is the right answer for this particular reaction. So these two numericals, these two questions are from the chemical kinetics chapter, and these are the most important one because they appeared in the many of the competitive examinations.